Alrighty, so this is the day before the assessment. This is the day before the long Thanksgiving break. So yeah, let's go ahead and get started so we can get our breaks in and yeah, see what else is going on. So for questions 1 through 3, classify each triangle using its angles and each of its sides. So again, with number 1, A, I am not going to. I stand by, even though I hand drew this and I wrote this, I stand by my original statement that I am not going to make. Um, I am not going to try to make equiangular thing. It is an equilateral triangle, and that is what everyone knows it as, and that's what we're going to do it. It's kind of like with Mean Girls. If they can't make fetch happen, we are not going to make equiangular happen. So that's my call. All right, so for 2, classifying it using its angles. Using its angles, this one threw me off, and I had to look it up. When you're looking at an isosceles, so this is an isosceles triangle, but that's a classification with the sides. That's right, I wrote out isosceles with absolute confidence because I looked up how to spell it between films. But that is a reference to the sides, between the two sides that are equal to each other. In terms of the angles, um, in terms of the angles here, none of the angles are over 80 degrees. None of the angles are under 90 degrees. None of the angles are over 90 degrees. None of them are equal to 90 degrees, so they're all under 90 degrees. If all of the angles are under 90 degrees, there's only one other question you need to ask. Are all of them 60 degrees? In this case, the answer is no. Therefore, that means classifying this triangle by its angles means that it is an acute triangle. Alrighty. Next, with this third one, let's see here. So I've got one side, two sides, three sides. Now I've got one angle, two angles, three angles. So none of the angles are equal. None of the sides are equal. So, well, this one's obtuse. I guess I can say that. So this one's an obtuse triangle, and otherwise it's a scalene triangle. All right. So yeah, we'll move on from here. Let's see. Write the congruent statement for figure 4, then identify all of the congruent parts. So I kind of dodged on this one. I kind of punted on this one to Quagsire, but now we're going to formally take a look at this as a review and do this as part of the review process formally. So looking at the congruent statement, this is 100% serious, exactly the same way that it was with the similarity statement, except I would argue the congruent statement is a lot more serious. The order matters for both of them, but I don't know. It just seems like there's more at stake with the congruence one because of the certainty of information and the quality of the information as opposed to what you get when you just have a similarity. So um, yeah, so with this one, if it's AB, so if this is triangle ABC and I'm referencing triangles ABC, then in reference to ABC, then that means that this is triangle D, E, and F. And so that means that angle A is congruent to angle D. That means that angle B is congruent to angle E, which is already kind of intuitive because they're both right triangles, but we'll move on anyway. This would be true even if they weren't right triangles. We'll say that. And then angle C is equal to angle F. But not only does it mean that the angles are equal to one another, as it does with similarity statements, it also means that the sides are the same measurements as well. Notice I didn't say equal. They are congruent. They are the same measurement. They are an exact copy of one another. This is obviously an issue with perspective and really bad drawing skills, so we'll just keep the thing moving. Um, Again, between reference angle 1 and 90 degrees, that's AB. Between reference angle 1 and 90 degrees, that's DE. between 90 degrees and reference angle 2, that's BC, and again between 90 degrees reference angle 2, that's EF, and then finally between reference angle 2 and reference angle 2, reference angle 1, that's CA, and then between reference angle 2, reference angle 1, that is FD. And so, yeah, there we go. That's our congruent statement with all of our relevant congruent parts. And like I said, the drawing is obviously not to scale. I don't know what I was thinking. But we'll move on. Oh, we got some math now. Alrighty. If triangle ABC is an equilateral triangle with side AB equals 3x squared and side BC equals 5x minus 4, find the value of x and the measure of each side. Well, thankfully, I have two sides that I can measure from because, again, if you have just an x statement that says something is 3x plus 2, that doesn't really mean anything. It could mean anything. It doesn't matter. Nothing. You can't get anything from that. But if you can set 3x plus 2 equal to something, now you've got something. Now you've got something you can work with. In this case, I've got an equilateral triangle. And I've got one side and I've got another side. Because it's an equilateral triangle, that means that I know this side equals this side. So 5x minus 4 equals 3x plus 2. So I'm going to subtract 3x from both sides. That gives me 2x. Add 4 to both sides equals 6. X equals 3. All right. So find the value of x. Found it. And the measure of each side. Well, this is actually going to be pretty straightforward. The measure of side 1 equals side 2 equals side 3 equals 3 times 3 plus 2, which is equal to 9 plus 2, which is 11, and there we go. That is the answer. Because it's an equilateral triangle, side 1 equals side 2 equals side 3, and then all I had to do was pick one of the two equations to put into it. I chose this one, and it would have given me the same result no matter what. So, yeah, there we go. Moving on. I've got triangle DEF with isosceles triangle with legs DE and DF. All right. So I know I can just, I'm going to pause right there. So D, E, F, and then DE is 2x plus 5, and DF is x plus 11, and then EF is just 14. Find the value of x and the measure of each side. I don't feel bad about saying this now, but I go to a problem generator for some of these, and I do a quick look, and I say, yeah, this looks good, this looks fine. I did not look too deeply at this one. I have to find the measure of each side. It gave me EF, so that's pretty funny. I happen to think that's pretty funny. So the good news is with an isosceles triangle, isosceles is a classification based on sides. And so that means that that means that two of the sides are equal to one another. So does that mean that 2x plus 5 equals 14? Or does that mean that x plus 11 equals 14? No, but it says the base equals, the base EF equals 14. Well, the base of the triangle is always going to be this. The base of an isosceles triangle is always going to be the part that's not the identical legs of it, I suppose you could call them. And so what that means is I can go with 2x plus 5 equals x plus 11. I'm going to subtract x and then subtract 5 from both sides. That gives me x equals 6. Pretty straightforward. So I'm just going to feed in. DE equals DF equals 6 plus 11, which equals 17. And we already know EF equals 14. So there we go. All right. So we're doing pretty well. We're finding sides using triangle identities, and onward ho. All right, triangle GHI is a scaling triangle. Oof. All right, so that means it could be anything. So I've got GHI. So these sides could be anything. GH is x plus 4. HI is 2x minus 1. And then GI is 3x minus 5. The longest side is 13 units. Okay. All right, so longest side is 13 units. Find the value of x in the measure of each side. Oh, bugger. All right. Well, equals x plus 4. I'm willing to bet that 3x minus 5 is going to be the longest side because, yeah, well, let me think. Well, just kind of reasoning it through. Let's logic this through. If x equals 1, then that means this is 5. That means that this is 3, and this is negative 2. All right, well, x equals 1. That's not great. All right, let's do 4. 4 plus 4, that means that this is 8. That means that this is 8 minus 1 is 7. That means it's 12 minus 5. That's going to be 7. All right. So let's do 6 plus 4. So let's do 6. X plus 4 is going to be 10. 12 minus 1 is going to be 11. And then 18 minus 5 is going to be, so 18 minus 5 is going to be 13. So it really depends on, so the longest side is going to be 13 units. So let's see, I am not sure how to solve this one outside of guess and check. This is actually a deviously good problem. Let's see, because it really depends, because depending on which value x plus 4 is, then that really affects which one is going to be 13. Okay, let's try this. Let's set each one of them equal to 13 and see what we get. So if the long side is x plus, if the longest side is 13, find the value of x and the measure of each side. So let's set each one of them equal to 13 and see what the value of x is. And the smallest the smallest the value of x, the longer the side is. Let's logic this through. So if it's 13, then x plus 4, x has to equal 9 for GH to be the longest, for GH to equal 13. Let's see. So I think that, yeah, I think I know what I'm going to do. So for 3x minus 5 equals 13, 3x minus 5 equals 13. So I'm going to add 5 to both sides. So that gives me 18. 3x equals 18. So x equals 6. So x equals 6 for GI to equal 13. And then for 2x minus 1, longest side, that equals 14. So x has to equal 7 for HI equals 13. Okay, so I've got x equals 9, x equals 6, and x equals 7. First of all, you're not going to find something this tough on the assessment. This is just a fun little brain teaser. So what does this mean with the value of x on each side? So I have to find the set value of x when when the longest side is going to be 13 units. Well, what this means is, well, I don't know which one is going to be the longest side. So let's see, 13, and well, it would help if I knew what the perimeter was, but I don't. And all three of the sides are different. Okay, I think I got this. So what it's going to take is it's going to take a little bit of math, going to take some guessing and checking, but I think I got this worked out. So what it's going to take is I'm going to have to assume that one of these is equal to 13. Then what I'm going to do is I'm going to solve for x. Then I'm going to put x back into each of these sides. And if any of the sides is greater than 13, then that side that I originally started with can't possibly be the longest side. So we'll start with x plus 4 is longest. So that means x plus 4 equals 13. So x equals 9. Yeah, so x equals 9. All right, well, if x equals 9, that I can feed this in. All right, well, I know immediately that's not going to work because at 9 times 3 is 27 minus 5 is 22. That's not going to work because if this side is 22, then the longest side isn't 13. So x plus 4 can't be the longest side. All right, let's try 2x minus 1. So let's try 2x minus 1 equals 13. So 2x minus 1 equals 13. 2x minus 1 equals 13. I'm going to add 1 to both sides, gives me 14, x equals 7. All right. So, well, I mean, again, I put 7 into 3x minus 5, and that's 21 minus 5. That gives me 16. That's not going to work either. Yeah, so 21 minus 5, that's 16. All right. Well, I mean, that kind of leaves only one option here. So if 3x minus 5 doesn't work, then if 3x minus 5 doesn't work, then I guess I need to figure out another problem and then eliminate this problem and then reorder the paperwork before it shows up. And then, of course, edit out this part of the video. Let's say, all right, 3x minus 5 equals 13. 3x equals 18, so x equals 6. All right. So if x equals 6, then x plus 4, yeah. So x plus 4 equals 10. All right, that's less than 13. And 2 times 6 minus 1 is 12 minus 11. Oh, well, all right then. X equals 6. Woo! Woohoo! Oh, man. All right, okay, okay. I can appreciate a challenge every now and then. But let's go with each of the sides. So, all right, well, each side is, we got a side that's 13, we've got a side that's 10, and then we've got a side that's 11. And so those are the three sides. I'm perfectly happy leaving it that way. And if you all can come up with that answer, then by George, I'll buy you hot chocolate. There we go. I was going to buy you something else, but then I remembered you're in 9th grade. All right, if triangle JKL is an isosceles triangle with legs equal to that, so if you're told that you have an isosceles triangle and the legs measure something, what that means is, all right, JK, first things first, JK and L, and the legs measure something, they're referring to the parts that are, to the side parts that are going to be equal. So JK is 4x minus 3, JL is 2x plus 5, and then KL equals 13. Did it again. Find the value of x and the measure of each side. Well, I found KL. That didn't take any time. Again, I'm just going to set these equal to each other. So 4x minus 3 equals 2x plus 5. And again, you have to know what the identity of, you have to know the characteristics of an isosceles triangle, and you have to understand what the math is around them. Otherwise, you could set 4x minus 3 equal to 13 or 2x plus 5 equals 13 and just completely throw your math off on this. So that gives me 2x equals 8, so x equals 4. So I found the value of x, and then I'm just going to say jk equals jl equals 2 times 4 plus 5. That's 8 plus 5 equals 13, and there we go. If you have it set up correctly, the math should really just fall into place without a great deal of trouble or worry. All right, so MNO is an equilateral triangle with sides MN, x plus 6, and side 2, 6. Find the value of x, and all right, 2x equals x plus 6. Oh, for crying out loud, I don't even have to do algebra for this. So each side is 12. Each side is 12, and x equals 6. And it's like, I don't even have to do math for this. 2x equals x plus 6. So 2 times x equals x, some number, plus 6. So if I add 6 to something and it's equal to twice of itself, that means that x equals, that would mean, So okay, well, let's work it back way. Let's assume that I'm guessing that x equals 6. 6 plus 6 is 12. 2 times 6 is 12. There we go. All right. I guess I guess I just feel a little let down by that problem because of this one up here. I don't know. It's hit or miss sometimes with these problem generators. All right, so got a couple more problems we can test out, or we can see that we're testing out on with this. All right, I've got triangle A, B, and C. All right, so I don't know anything about the relationship between the angles or the triangles. All I know are the angle measurements. So it's 3x plus 10. B is x plus 20. And then C is 2x. And then I have to find x and then the measure of each angle. All right. Again, when we're dealing with the internal angle measurement of triangles, you add all of them up and it equals 180. So 3x plus 10 plus x plus 20 plus 2x equals 180. I'm going to combine all of the x's together, and then I'm going to move all of the numbers over to the side. So that's going to mean 10 and 20. That's going to give me 150 over here. 3x plus 2x, so that's 5. That's just going to be 5x. Wait, it's going to be 6x. Aha! Thought you could fool me. Thought you could hide. So that's going to be 6x equals 150. So that's going to mean x equals 25. There we go. I found x. So angle A is going to equal 3 times x plus 10, which is going to be 75 plus 10 is 85. Angle B, I mean, this is clearly not to scale. Angle B is going to be 25 plus 20, which is 45. And then angle C is going to equal 2 times 25, which is 50. Well, I mean, they're technically it's technically an acute triangle. All of them are less than 90 degrees. So it could be to scale. No, it's not. It's not to scale. I don't know what I'm saying. All right, let's see. Triangle DEF. Oh, looks like, oh, all right. All right, here we go. So I've got triangle D, E, F. There we go. D is 2x, and then E is x plus 15. And then I have to find the value of x and the measure of each angle. Well, F is easy. It's already known. It's a right angle. So that means that 2x plus x plus 15 equals 90. And I don't have to worry about, normally I would say, well, let's, do everything out of 180. But the thing is, if I know that F is a right angle, then I know that F is 90. And if I can account for 90 degrees, why would I add it in if I'm just going to subtract it out again? So these two added together, I know equal 90 degrees because these two plus this is 180. So why not just set these two equal to 90, make my calculations easier? So that means 3x equals, I think that's 75. So 90 minus 15. Yep. So x equals 25. So what that means is angle D equals 50. Angle E equals 25 plus 15, which is 40. And of course, angle F, because we were asked to find all of the angle measurements, is going to be 90. All right. Let's see. Oh, all right. Okay. All right. I see we're getting a little bit more exciting here. So G, H, I. Side HI is extended past point I. Alrighty. The exterior angle at point I is 5x. The two remote interior angles are angle G equals x plus 1, and angle H, which is 2x. Find the value of H in each measure of each triangle. Well, that is just devious. So, well, all I'm going to do is, well, I have to find angle I also. But I need to find x in order to solve for I. So I'm going to use the exterior angle theorem and set 5x, and this is just to find x, equals 2x plus x plus 1. And so I don't like where this is going. But let's see, 5x and then equal to x plus 1 and then 2x. So that means a measure of each triangle. I don't like this. Exterior angle at point I is 5x, all right? The two remote interior angles are angle G equals x plus 1, angle H, which is 2x. Find the value of x and the measure of each angle in triangle GHI. This is going to be a really weird number. But I always say trust the process. So 5x equals 3x plus 1. So 2x equals 1. X equals 0.5. This doesn't seem right. Okay, I need to set up the equalities differently. I need to set up the equality. I think I'm going to have to find a different way to do this one. Because if this was all that I had to worry about, then I would definitely need to. I think I know what I need to do here. So I think I know what I need to do here. So let's see. I need to incorporate 180 in it in some way. So let's go with All right, so the problem that I have is that if I incorporate these constants as they are, then basically I'm just going to end up with what I had before, which is x equals 0.5, which technically is correct, but it's not going to help me out because I have to scale all of this up to 180. So wait a minute. So let's say x equals 0.5. Is there a number? Is there a number, another number, I'm going to say y, that I can scale these up to so that these all equal, so that these all work out to each other. So is there a, so that, is there, I've got to incorporate 180 in some way. How am I going, you know, I honestly, I'm thinking about it. X equals 0.5. I've always said that if you trust the process, then the answer will be right. If you get weird numbers but you do the right process, then the numbers are weird, but you did the right thing and you did it the right way. Find the value of x. That's the value of x. Find the measure of each angle in GHI. So, all right, angle G equals 1.5, angle H equals 1, angle I equals 180 minus 2.5, 177.5. I mean, those are the numbers. Those are the numbers. That's the process. If I puzzled around about this. I actually took a break, walked around, went to a dry erase board, tried to figure out a way to incorporate 180 to try to scale this up. I even did a bunch of guess and check, did an Excel spreadsheet, and I said, is there a way that with this kind of a ratio, I could boost this up and make this into 180? And the answer is no. There are no combinations of these angles and this exterior measurement that will give me 180 degrees adding up inside the triangle. And except for this one, where x equals 0.5 and I ends up being one of the most obtuse angles I have ever seen. But so yeah, this is the process. These are the numbers the process got me. So we're just going to keep going. If you were to turn this in, I would say, yeah, I was confused too, but those are the best numbers I got. All right, in triangle JKL, side L, all right, so I've got J Then I've got KL, yeah, and is 3x plus 5. We'll get a chance to practice the process again. Is 3x plus 5, and the adjacent interior angle at point L is x plus 15. All right. Find the value of x and the measure of the exterior angle. Oh, okay. All right. I think I see where this is going. Okay. All right. I can see this. So x plus 15 and 3x plus 5, those equal 180. So 3x plus 5 plus x plus 15 equals 180. So that means 4x equals 180 minus 20, 160. So I think that's 40. 160 divided by 4 equals, yeah, x equals 40. So there we go. There's that x. So the exterior angle, so let's see, the measure of the exterior angle, I'll say exterior, is 3x times 5. So the 3 times 40 plus 5. So that's equal to 125. So L, angle L, equals 180 minus this. So that's going to be 155. Yeah, is going to just be 55. So that means that angle J and angle K, let's see, we got angle J and angle K. What do we know about angle J and K? Point L, this is the angle K, and measure the interior angles J, K, and L. Well, we know that they add up to 125, and that's pretty much all we know about them. We don't know anything else about them really. All we know is that they add up to 125. So other than that, I mean, I guess we can make them whatever we want to, but I just kind of want to split it evenly as best I can. So I'll make this one 63 and this one 62. And yeah, if you want to split it up in a different way, that's perfectly fine. Sometimes it's just I mean, I can't find any evidence I can't find anything in the problem that says anything about triangle J and triangle K, that they're not equal, that they are equal. All I know is that you add them up and they equal 125. So that's what I'm going to go with. All right. So triangle MNO. Let's see. M, N, O. M equals X, very simple. N equals 2X minus 10. And then O is X plus 20. All right. Find the value of X and the measure of each angle. Oh, well, all right then. 2X minus 10 plus X plus 20 plus X equals 180. Relatively simple problem. I guess it's kind of helping us out and giving us a break since given what all we've had to go through today. Let's see. So 2x plus x plus x, so that's 4x equals 180 plus 10 minus 20, so that's 170. Is that? Let's see, 180 minus 20 plus 10 equals, yeah, 170. So x equals, so that divided by 4, yep, x equals 42.5. All right. So we have to find each. So we found the angles. So we found x. Now we have to find each of the angles. Angle M equals 42.5. Pretty good stuff. Angle N is going to equal 42.5 plus 20, so that's going to be 62.5. And then angle O, I don't want to mess with doing all that, so I'm just going to do 180 minus 42.5 minus 62.5, which is going to equal 75. And there we go. That's all three of the angles from the triangle that we had. All right, we've got this last little one here. Let's see, we've got triangle RST congruent to triangle XYZ. What is the value of X? All right, so I've got triangle R is congruent to X, then S is congruent to Y, and then Z, and then T is congruent to Z. What is the value of X? Oh, well, 3x minus 5 equals 16. So plus 5, 3x equals 21, x equals 7. It was quite the buildup for how long it took me to draw that. All right. Well, let's see. If triangle ABC, all right, so triangle ABC is congruent. ABC, A, B, B, C is congruent to D, E, F, so D, E, F. Then what are the values of X, Y, and Z? All right. So where is X? Oh, here we are. 8x plus 2 is related to, reference angle 2, and it's related to 82. All right. So 8x plus 2 equals 82. So 8x equals 84. X equals 84 divided by 8. Oops, no. 84 divided by 8 is 10.5. There we go. Let's see, Y is right here, so it's an angle reference angle 3, which is equal to 64. Well, 8y equals 64, y equals 8. Finally, Z is, oh, well, all right, well, this is a nice little twist. So Z is equal to 4z minus 6, and what is that reference on the congruent triangle? 3z plus 4. All right, so that means that 4z minus 6 equals 3z plus 4. Well, I'm going to subtract 3z from both sides. That just gives me z. Then I'm going to add 6 to this side, gives me 10. And, oh, well, there we go. Z equals 10. Again, given how much time I spent drawing these, I was kind of hoping there would be more to it than that. But, all right. Well, if you got through this review and you got through all these problems, especially that one brain teaser, whew, my goodness, then you are ready for the first assessment. And then, once you're done with that, then and only then are you ready for your first, well, not first, I mean, you probably had Thanksgiving breaks before, but then you're ready for your Thanksgiving break.